Carver-Joint joint forming machine. There's only a handful of these in the country. I got it about a month ago. So this is 10, 11 months to build. So I can make a 2440 joint in about a minute and a half. I've got some pre-prepped up 28 by 2 mil tubing. This will make a double ender. I'm a little out of practice on this, so it'll either go really well or really poorly. We start by inserting the bottom. We start by grabbing another tube and inserting it into the scroll jar. Pair of calipers, set the length off of the face. It's all fairly precision machines. Lock the scroll. There's a pair of speeds and a lot of foot levers. So this will start the initial spindle. And we've got two burners, one for the rim and one that's a box burner. So we're heating up the lip and the mask, and they're on hand controls. You can adjust the pressure. We got pairs of joint forming machine. So I'm just getting the torches set up. I'm at a nice comfortable speed, and I want this edge to roll back in but not past the bead. And if I need to, I can tap it a little bit to kick it into a high speed mode, and it'll flare for me while I'm actually forming. That's what I'm looking for. So we've got this roll back. Again, I'm looking for this bead to just be inside that form to fill the tool. Flare it a little, I'm happy with it. Nice and slowly, you bring up the bottom carriage, add some speed, press it in, lock it down. That's it. 2440 joint. So, you know, this one's a little underfilled.
Can you go through that whole
process
without a plane?
Oh,
just to show the mechanisms.
Yeah, let me kill the flame on this box. So let me pull this out because it's screaming hot. After this, it would end up getting ground. So we run a bunch of these. We've got a pin board set up, and we'll run a bunch of them, then run the second end on them. So there's a lot of motions for articulation in this carriage, and that's really the magic of this machine. When you buy stuff from Herbert Arnold, you buy the lathe as one component, you buy the carriage as a component, you buy the torches as a component, you buy the foot pedals as a component. So all these are separate. They build them a la carte. So this is on-off for the spindle on the left pedal. The right pedal is a momentary pulse to increase the speed. And there's two speed controllers. So I can really move this incredibly quickly if you want to do a lot of centrifugal flaring or conical pipe flanges. This is the larger of the two models. It's got a mag brake, so it'll stop and lock and hold the chuck for you. But this has a 125 or 127 millimeter bore, so I can chuck up 5-inch tube. I have a vacuum chuck and blow hose for it as well that I can feed through here to actually blow and inflate joints. So what actually does the forming on here, the box burner heats up the body, the rim burner heats up the end of a joint. So I have done. It's a little ugly. So this rim burner, which is screaming hot, heats up the end here, and this large box burner underneath heats up the center section. And to make this initial depression, there's a foot lever that raises the cradle. And this is a piece of cast iron that freely rotates. Again, I'm not touching any of it because it's screaming hot. So that forms the outer shape. And you have to form this very slowly. We've got a crossfire set up by hand that we normally operate, we have for many years. To form the inside, the mandrel slides in, compresses to thickness, then trues up the exterior bead. So in real time, you're using your left foot to increase the speed, the right foot to form the outer, the right hand to start forming the inner diameter, compressing and squeezing. So it takes a while to get the rhythm of the machine, But once you have it, you can make a joint in very, very short time. So we'll run out another one. I've got a Carver-Joint crack off machine as well. That we just take full lengths of tubing, put a score line in it, heat pop it. It takes about 6 seconds to break up sections of tubing. And we try and use the least number of fire cracks for each one of them. So again, here's, I need to let my pilot play. Normally I also have beeswax setup and a master joint, and I'll check it really quickly to make sure that I'm on diameter and I haven't missed anything. But for a quick demo, we're just fine. Box burner. Wipe off the tubing. Place it gently. Line it up. Figuring out all the heights and the offsets actually took a bunch of math that Herbert Arnold did not provide. So despite being robust German engineering, the North American joints are different than the European. North American joints, we have a bead on the ends, and the European joints are more of a flat finish. Yeah, squared off, flat. Europeans also typically utilize a.
And it's preferred to have it spinning towards you rather than away.
On this one, it's spinning towards because of the way the chuck jaws open up. As always, Chris the demo. There we go. We'll see if I get an even heat base. Again, I've only had this machine for a little over a month, so there are more intricacies to it than I'm used to, but we'll get there. So again, I want to try and get this lip to roll just inside of that carriage. I can tell that ring burner's hotter than the box burner. Surprisingly, these don't need very much annealing afterwards because you're heating everything up uniformly. Slide it in, speed up, and gently raise the tooling block down just the lip. And if you want, you can glaze the joint, and they run extremely true. I'm just looking to bring up a light glow. Nothing on the inside, just the outside where everything touched. There's a little bit of haziness on the interior of the joint, and all of that gets ground away. And that's typical of hand forming as well. So there's not a whole lot of these in the US, but for our small shop where we do a lot of prototype, R&D, quick turnaround stuff, it's an invaluable tool. And I'm thankful to have one.
Great. Thank you, Jared.
Sure.